Today we'll be looking into magnetic fields and measuring the subsequent force between two magnets in a controlled environment. For this lab, my collaborators were Tilly Druce, James Elias Raya, and Sydney Edwards. The aim of this lab was to measure the force between two magnets as a function of their separation between their centers of mass. The physics principles. In this lab, we looked into magnetism, which is the force that pushes magnets apart or pulls them together, as displayed in this diagram. The magnets were placed in a tube for this experiment with their south poles facing one another, causing them to be repelled. This is caused by the magnetic fields, which can be calculated using the Biot-Savart law. The force between the two magnets ended up being calculated using the formula magnetic force is equal to C1 over R to the A, showing the function relation that the closer the magnets are, the higher the force pushing them each other away is. In this equation, the F with the little m is the force of the magnet, C is the permeability constant, or 1.257 times 10 to the negative 6, and R is the distance between the magnets. For this reason, only A needed to be calculated. There are a number of uncertainties to consider within this experiment. Firstly, the lead weights which were used came in at 8.3 grams with an uncertainty of plus or minus 0.15 grams per weight. The other uncertainty affecting the measurements would have been the accuracy of the ruler and the human eye, smaller measurements becoming harder to decipher as the force got stronger and the magnets moved less per weight added. This is hard to calculate for and could only be fixed by more precise tools or computer software. The main uncertainty was calculated with the slope of the linear graph shown in the results page. It was calculated using the simple formula max slope minus min slope over 2, with each slope being calculated with the classic y1 minus y2 over x1 minus x2. With this method, we got an uncertainty of 0.19. Plus or minus 0.19. The experiment is shown here in this short video. It consisted of two 9.3 gram magnets, a clear plastic tube, and several 8.3 gram lead fishing weights, and a ruler to measure the separation of the magnet centers of mass. The video pictured here is the process of the experiment. By adding these lead weights of a known mass, we were able to determine the force, as is shown in the results section. It was important to include the weight of the top magnet as well, which was 9.3 grams. The distance between the centers of mass was taken after adding each weight and then compiled into a spreadsheet to give us our final results section. Once we got the data from the experiment, it was put into Excel to find a value, A, using the same formula to derive out the A out of F is equal to C1 over IA. Logarithms were used to separate this out, as shown in this area here. We could then graph this using logs into a curve of the force and the weight added and a linear line that ended up giving us the A value, which ended up being close to 4.06 plus or minus 0.19, which was calculated earlier. With this number, the equation could be completed with the permeability constant, the measured distance, and our now known value to find the magnetic force separating the two magnets at any point. Thanks for listening to my presentation. I hope it made sense and you enjoyed it.